In this video, I'm going to talk about electric field E. Okay, electric field we indicate with E. Okay, measured in Newton per Coulomb. It's basically electric field is nothing but force per unit charge. Okay, this indicates the E. We know that according to Coulomb's law, F is nothing but K Q1 Q2 over R square. So E is nothing but F over Q. So Q get cancelled out. Which Q, it doesn't matter, Q1 or Q2 divided by Q. One of them cancel out. So electric field is nothing but K Q over R square. When it comes to the electric field, I noticed that many textbook uses 1 over 4 pi epsilon naught instead of K, so I'm going to follow the same rule. I don't know the exact reason, but this is the formula for electric field. Electric field is a vector quantity, so that's the reason I'm showing you with the vector on E. Electric field, another important point, always starts at positive, so it always goes out of the positive charge. Okay, and it always goes into the negative charge. Into the negative charge, the electric field is coming into the negative charge. This electric field we are indicating with these lines. These are called electric field lines. These electric field lines are representing the field direction at each point. Or we are showing electric field in the form of field lines. So the important points we learned so far are electric field is nothing but force per unit charge. Okay, it's a vector quantity, and the formula is E equal to 1 over 4 pi epsilon naught Q over R square, or E equal to F over Q. And electric field lines always starts at the positive charge and ends at the negative charge. We are finding electric field at point P due to 3 equal point charges. Okay, so assume that all 3 equal charges or 3 charges, equal amounts, Q1, Q2, Q3 are equal to Q. Now these 3 charges are placed on a y-axis, and we want to find electric field at point P, which is on the positive x-axis side. Okay, Q2 is placed at the origin, and Q1 is on the positive y-axis at d distance, and Q3 on the negative axis at d distance. So here the point P is distance x from the origin. Now the electric field E1, E2, E3, E1 equal to K Q1 Q2. So instead of K, I'm going to use 1 over 4 pi epsilon naught Q1 over R square. Here R is nothing but d square plus x square. Okay, so square root of d square plus x square whole square. Okay, so this is nothing but Q1 over 4 pi epsilon naught d square plus x square, and that electric field is going down with an theta angle, theta 1. Okay, theta 1 is defined here, tan inverse of d over x. Now E2 is going to be the same quantity, Q2 over 4 pi epsilon naught. Here it's going to be x square only on the x-axis, and E3 equal to Q3 over 4 pi epsilon naught, and that distance is d square plus x square whole square. Okay, square root and square get cancelled out. We'll end up with Q3 over 4 pi epsilon naught, and here you have theta 3. That's E3. E2. Now we're adding all 3 vectors. So look at here, E2 is on the x-axis, E3 is on the negative side of the x-axis. I mean, in the sense with a negative angle of x-axis, and E3 is positive angle of x-axis. Okay, so this theta 3 is same as theta 1, so I'm going to take that as theta. So this E3y component and E1y component, they cancel out each other. Okay, all we end up with the E1x component and E3x component on the x-axis. So the resultant electric field E must be E2 plus E1x plus E3x, because the y components are going to cancel out each other. So E2 we already know, which is Q over 4 pi epsilon naught over x square, plus E1x is nothing but, can I write this as Q over 4 pi epsilon naught x square plus d square times cos theta. Okay, that's E1x, and E3x is going to be the same, Q cos theta over 4 pi epsilon naught x square plus d square. Okay, now Q and 4 pi epsilon naught are the same. At the same time, can we define cos theta here? Can I write this cos theta equal to x over square root of d square plus x square? Okay, I'm going to use that. So here E equal to, I'm going to pull out Q over 4 pi epsilon naught, okay, and 1 over x square plus x over x square plus d square. I mean, cos theta is nothing but, I put it as x over square root of x square plus d square, right? So here x square plus d square and x square plus d square, which is 3 by 2. So x square plus d square whole to the power of 3 by 2 plus x over x square plus d square 3 by 2. So here these two quantities are same, so I can write them as 2x. So electric field at point P, because of 3 point charges, the equal amounts, is Q over 4 pi epsilon naught 1 over x square plus 2x over x square. I don't know why I'm doing x2, it's a square. This is also square, not x2. So x square plus d square to the power of 3 by 2. This is the electric field at point P because of 3 point charges. Now, in the same video, I'm going to continue with the long line of charge. Here, I'm trying to find electric field at point P due to long line of charge. So, I'm going to define a term called lambda. Lambda is charge per unit length. Okay, so this is just Q over L. Lambda is Q over L, charge per unit length. Now, I'm going to define a small length here. So this length is nothing but dl, because the total length is, assuming this is the total L. So here Q is the total charge, L is the total length. Now dl, I'm going to define a small amount of charge dq, which is the charge placed in this area, okay, in the dl length. I'm going to define that as dq equal to lambda total, charge per unit length times dy or dl in this case. Now I'm going to define dE. dE is the electric field at point P because of the charge here, charge in this area. So I'm going to define that as right here, this is dE. Okay, so dE equal to 1 over 4 pi epsilon naught, okay, and dq over the length. I'm going to take this as x, and I'm going to take this as y. Okay, so this is square root of x square plus y square. So dq equal to x square plus y square times whole square root get cancelled out, so d equal to 1 over 4 pi epsilon naught dq over x square plus y square. Now electric field at point E because of that small length of charge. Now if we look at here, each charge, the electric field is going to be something like this, right? Now so this is because of the charge here, this is because of the charge there, this is because of charge here, like that. Now all these electric fields, the y components, are this y component and this y component cancel out, this cancel out, this cancel out. So all the y components are going to cancel out. We'll end up with only x components. So electric field equal to, total electric field equal to Ex equal to integral of dE times cos theta. Okay, so dE is nothing but, I'm going to pull out 1 over 4 pi epsilon naught outside. Actually what I'm going to do, I'm going to convert this dq into dl. So 1 by 4 pi epsilon naught lambda times dl over x square plus y square. So lambda over 4 pi epsilon naught, I'm going to pull this out, we'll end up with cos theta over x square plus y square times dl. Okay, dl, l is the length, y is also length, so it's not going to make any difference if I change l into y, okay, because l and y are the same components, okay, but they're not equal, but that's fine. Okay, so what I'm going to do, lambda over 4 pi epsilon naught integral of cos theta over x square plus y square times dy. Okay, this is dl and dy, they are the same components in the y-axis. Here we are integrating this minus pi by 2 to pi by 2 because the theta value will not go beyond that 90 degrees. From here I can write tan theta equal to y over x. So y equal to x tan theta. If I differentiate this, dy equal to x times d theta over cos square theta. Okay, and we know that cos theta is nothing but x over square root of x square plus y square. Okay, so 1 over x square plus y square equal to cos square theta over x square. So I'm going to substitute these values in there. So E equal to, so you can see from here I kept the cos theta as it is, 1 over x square plus y square, 1 over x square plus y square equal to cos square theta over x square. I'm going to keep that, and then dy equal to x times d theta over cos square theta. I'm going to pull this over here. Now cos square theta get cancelled, x square x get cancelled out. So at the end we'll end up with E equal to lambda over 4 pi epsilon naught. Actually I should have kept this upper limit and lower limit here because it's theta. So times cos theta times d theta. Now I can substitute cos theta equal to this quantity, x over x square root of x square plus y square. If I substitute that value, or equal to lambda over 4 pi epsilon naught, sorry, instead of substituting that I'm going to integrate this. If I integrate it, I think I forgot the x, I'm going to pull that x out. If I integrate it, it's going to be sine theta from pi by 2 to minus pi by 2. Okay, so the electric field at point E because of the long line of charge equal to lambda over 4 pi epsilon naught x sine pi by 2 upper limit minus lower limit, right? So sine pi by 2 is 1, minus of minus 1, which is positive 1, so 2 get cancelled out. So this value is 2 get cancelled out. So electric field at point P, because of the long line of charges, lambda over 2 pi epsilon naught times x. Okay, I'll stop this video here. In the next video, I'm going to talk about electric field due to a ring of charge. Thank you.